Chapter 10 Review. For numbers 1 through 4, we are assuming that the proposition all whales are a mammal is true, so we need to determine if numbers 1 through 4 are true or false. So number 1, all non-whales are non-mammals. Obviously, we can have other animals that are not whales, but still mammals. For example, dogs and cats and people. So this is false. If a mammal lives in the sea, it is a whale. So the whales are not the only mammals who live in the sea. There are seals, there are dolphins, there's even the occasional squirrel. So whales, not the only mammals in the sea. So once again, this is false. All mammals are whales. So once again, this is not true because there are other mammals that exist that are not whales, like dogs, cats, and people, once again. So this is false. And number 4, all non-mammals are non-whales. And this is true because if it's a whale, then it's a mammal. So if it's not a mammal, then it's not a whale. So true. For numbers 5 through 8, we need to decide whether this statement represents inductive or deductive reasoning. So number 5, a group of students were given 3 descriptions about a person's job. They were then told to decide what kind of job title the person has. So with deductive reasoning, you're making observations given broad statements and making a specific conclusion. With inductive reasoning, you're making a conclusion based on a pattern that you can't really say for sure, say concretely that it is 100% true. So with number 5, given descriptions about what a person does, that doesn't necessarily mean that we know for sure what their job title is. You're making a conclusion based on a pattern. So because of this, number 5 is an example of inductive reasoning. I'm just going to put an I for inductive. So number 6, when traveling in a car on a family vacation, I noticed that I could see the ocean to my left and palm trees to my right. I concluded that my family and I were going to the beach. So with this one, you are seeing concrete evidence. You know that you can see the ocean, you can see the palm trees, and based on this, you come to the conclusion of where you are going. And because of this, because of your concrete evidence and making a specific conclusion, you are using deductive reasoning. Number 7, Sammy asked her friend Amy to give her a good reason to get a summer job. Amy gave Sammy 4 good reasons. So this is kind of a tricky one because there isn't necessarily a conclusion, but just based on the fact that there's a pattern, knowing that there's no concrete 100% true answer, we are going to say this is inductive reasoning. Okay? Number 8, the neighbors' cars are in the driveway and all the lights in the house are off, so they must be sleeping. So again, we have evidence. Their cars are in the driveway, everyone is home, all the lights are off. So they're home, the lights are off, they must be sleeping. This is deductive reasoning. Okay, let's go on. So for number 9 through 12, we need to say whether it's always, never, or sometimes true. So number 9, quadratic equations have 2 solutions. So quadratic equations are equations where you have y equals x squared. What's important is that the x has an exponent of 2. And when you graph this, it looks like a parabola like this. So the solutions are where it intersects with the x-axis. Sometimes you can have a parabola that doesn't intersect with it at all, and in that case you would have no solution. This is especially true when y is a negative number. So for example, if you have negative 7 equals x squared, you would never be able to solve for x because when you square a number, you're never going to get a negative number, even if x is negative, because a negative times a negative is a positive. Every time you square something, it's always going to be positive. So if y is negative, that means you have no solution. So 9 is sometimes. So I'm going to put an S for sometimes. 10. If you graph a linear equation, the graph will be a straight line. So a linear equation means you have an equation where x has an exponent of 1, and in this case that is true. All linear equations have a straight line, whether it's slanted or vertical or horizontal. It's always going to be a straight line. So in this case, the answer is always. Number 11. When multiplying both sides of an inequality by a number, you must reverse the direction of the inequality symbol. So if you recall, inequalities are things like lesser than or greater than. So let's say you have, I don't know, let's say 3x is less than 9. So if you multiply both sides by 1/3 to get rid of this 3, are we going to have to flip around this sign? Well, if it's positive, then you don't. But let's say we wanted to do negative 1/3. In this case, you would switch it. You would flip it around. So the answer for number 11 is sometimes. It depends on whether the number you're multiplying by is positive or negative. Number 12, when you take the absolute value of a number, you are making the number negative. So remember, absolute values are those straight lines. So let's say you have a -7 in there. Absolute value is the distance of this -7 to the 0 on the number line. So actually, it's the opposite of this statement. Every single time you have an absolute value, it becomes positive. Even if this were already positive, it would stay positive. So for number 12, the answer is never. Okay? So let's move on. Now we're going to the chapter test. Okay, for numbers 1 through 3, choose which argument is valid. So number 1, if I oversleep, I miss breakfast. If I miss breakfast, I cannot concentrate in class. If I do not concentrate in class, I make bad grades. So A is, I made bad grades today, so I missed breakfast. So we know that if you miss breakfast, then you will get bad grades. But just because you get bad grades doesn't necessarily miss breakfast. There could be a number of reasons that you make bad grades. You could have not studied. You could have not done your homework. So A isn't necessarily true. B, I made good grades today, so I got up on time. So we know if you oversleep, you definitely make bad grades. So if you get up on time, so if you make good grades, that means you did not oversleep. So B is a strong contender, but let's keep going. When doing multiple choice, you want to read every single option. C, I could not concentrate in class today, so I overslept. So this is also an illogical conclusion because oversleeping might not be the only reason that you cannot concentrate in class. You could be sitting next to a friend who's being really talkative. You could have, like a crush on the person in front of you. The teacher could have like a booger hanging out of their nose. So not being able to concentrate in class is not necessarily because of oversleeping and missing breakfast. So C is also an illogical conclusion. D, I had no breakfast today, so I overslept. So that is also a strong contender. But just because you had no breakfast doesn't necessarily mean that it's because you overslept. We know that oversleeping makes you miss breakfast, but missing breakfast doesn't necessarily mean that you overslept. Maybe your mom forgot to go grocery shopping, or maybe you just, I don't know, were busy on Facebook in the morning and you didn't get ready quick enough. So right now the best answer is probably going to be B. Okay, number 2, if I do not maintain my car regularly, it will develop problems. If my car develops problems, it will not be safe to drive. If my car is not safe to drive, I cannot take a trip in it. So A, if my car develops problems, I did not maintain it regularly. So we know that if you do not maintain it regularly, it will develop problems. but it doesn't say that every time it develops problems that it means that you didn't maintain your car regularly. So you want to avoid going backwards, saying, this is the conclusion, so therefore the statement that comes before it is true, because even though something causes something else, it doesn't necessarily mean the thing it causes is caused by that particular thing. And I recognize that sentence kind of was probably hard to follow. I can't even follow that. Okay. So B, I took a trip in my car, so I maintained it regularly. That is a strong contender. C, if I maintain my car regularly, it will not develop problems. So just because you maintain your car regularly does not mean that it will never develop problems. All it says is that if you do not maintain your car regularly, it will definitely develop problems. So that's not necessarily true. And D, if my car is safe to drive, it will not develop problems. And again, that doesn't make sense because you're kind of going backwards. So you don't want to look at a conclusion and say, okay, if this happened, then this backwards also happened. You only want to go forward, not backwards. So because of that, because we know that we took a trip in my car, that means that we maintained the car regularly. So the answer is B. Okay, number 3. If two triangles have all corresponding sides and all corresponding angles congruent, then they are congruent triangles. If two triangles are congruent, then they are similar triangles. So that means that all congruent triangles are also similar triangles. So let's look at your options. A, similar triangles have all sides and all angles congruent. This is true because this is true if they are congruent triangles, but not all similar triangles are congruent triangles. So A isn't necessarily true. B, if two triangles are similar, then they are congruent. Again, this isn't necessarily true. Just because all congruent triangles are similar doesn't necessarily mean that they are all congruent. By the way, just in case you forgot, triangles that are congruent means that everything is exactly the same. Similar triangles means that they have the same ratios of sides and the same angles, but they're not necessarily exactly the same size. It's like having, a big square and a little square. So they're not exactly the same size, but they're similar. If this one were to expand, it could grow up to be a big triangle like this one day. So just because they're similar doesn't mean they're congruent. C, if two triangles are not congruent, then they are not similar. Again, this is not true because case in point, these two squares over here are not congruent, but they are similar. So that's not correct. And D, if two triangles have all corresponding sides and angles congruent, then they are similar. So if we go back to here, we have this first statement, okay, they're congruent, and then we have the second statement, they are similar. So D is our correct answer. Okay, let's move on. Number 4, Cynthia is asked to list 5 duties of the president. What type of logic is Cynthia using? A, mathematical reasoning, B, inductive reasoning, C, intuitive reasoning, or D, deductive reasoning. So, let's see. So, for this one, since she is listing 5 duties of the president, she is working from broad information down to specific information. And with this kind of deduction, you're not let's see. When you're using inductive reasoning, you're trying to predict something that will occur in the future based on patterns. When it's deductive reasoning, you're using facts and observations. So for number 4, we're going to say D because it is based on facts and observations. 5, you can find the equation of a line by using 2 points that lie on that line. When is this statement true? Let's see. It is pretty much always true. I can't think of a way that it would not be true, unless we're using unless it's an absolute value equation. But then that would be two lines if it's absolute value. If it's a parabola, we wouldn't really call that a line, would we? No. Yeah. I think when it says line, they're talking about a straight line like this, using linear equations. So let's say 5a, always true, because if you know 2 points, then you can find the slope, and if you can find the slope, then you can plug in the point into your slope-intercept equation and find the y-intercept, and you can find the equation. Okay, 6. When using order of operations to simplify an algebraic equation, the first step is to get rid of the exponents. When is this statement true? So remember, order of operations, you want to use PEMDAS. Okay, so parentheses, exponents, multiplication, division, addition, subtraction. This is the order that you do everything in. So the first step is parentheses. But we don't want to say that it's never true that you start with the exponents, because if you don't have parentheses, then you would start with the exponents. So we would say B, sometimes. And that is it for Chapter 10 review and test. Hope this was helpful.